So here this is the complete procedure. Firstly we have to peel, then juice extracted by using the juicer, then addition of the different foaming agents, then whipping at different times, then drying, and we got the that optimized condition for the foaming agent and the foaming agent. Then we go for the drying in the microwave oven, and we for the from the 180 to 900 watt. Then we go for the grinding to prepare the powder. So from the previous trials we optimize here two methods of the foaming, that is foam with the guar gum, soya protein isolate and sugar with whipping time 6 minutes, and another one is the foam with the soya protein isolate 2.1 at 10%.
That one is already explained.
Okay, sir.
Directly conclusion.
So, yes, sir. So this is the optimal custom design we use for the optimization process. So this is the drying characteristics. Here these all are the observed parameters at the different drying power, and this. So here we determine that water activity, acidity, ascorbic acid, color value, del E value, that is the change in color, then overall acceptability and drying time. Here we consider there will be the water activities, drying time, and variation in drying color should be minimum, and other parameters should be maximum. On that basis we optimize the solution. So these all are the graphs.
Show madam,
yes.
directly optimize
Yes.
parameters.
So this is the superimposed plot where we got the different responses for the optimization of the microwave power, drying bed thickness, and foaming agent. So this is a previous. So this is the different responses we got is here, the predicted and the experimental values. Then this is the drying graphs. Then this is the conclusions. Here the initial moisture content of the Nagpur Mandalin was found after foaming, that is 90 to 89% weight basis. Then the optimum condition of drying of Nagpur Mandalin powder was the 543 watt microwave power. Here we consider 500 watt power. Then drying bed thickness is 3 mm, and the sample of soya protein isolate, GMC and CMC. Here these different concentrations are given, and the whipping time is 8 minutes with this optimized condition. Then here, thank you, sir.
Thank you, madam. Any question from audience? Any question? Thank you.
Thank you, sir.
Next one.
Actually, sir, we have that microwave power. They were 10%.
Okay, next, Mohini Nandi. Madam, skip all introductory parts.
A very good afternoon to all the dignitaries. My first presentation is regarding development of Chilonji nut grader cum decorticated. Myself, Dr. Mohini M. Dange, Assistant Professor, Dr. Panjabrao Deshmukh Krishi Vidyapith, Akola. Okay, basically to start with, first of all, we need to understand that this is a plant, and like if anybody has eaten that almond. So the outer coat is as such, and the inner is like this side, right side, and that is the outer coat, and the upper side is the flesh side. So now what we are doing, we need to last two things we can see pictures. We have to decorticate the kernel from that nut. Now next, we can see regarding the introduction, we get it from in India, and the major state growing are Chhattisgarh, Maharashtra, Rajasthan, and the major part what we are dealing here is ki nearly 3 to 4 kg from a tree we get, and they are sold at 100 to 125 kgs per kg, and if we process it or if we decorticate it, then the value will be increased to 1500 per kg. Now these are the
Ma'am,
videos.
keep
Yeah,
on this.
yeah, yeah.
Show your
Yeah.
direct your work.
Yes, sir. Yes, sir. So, protein content is high. It is used in sweets and all, and 52% of oil content is there, which can be used as a substitute for almond oils. Now, regarding my work objectives, first we developed it, and then we just studied the performance evaluation. So, this is the justification of the work. The hard coat or hard shell is seen outside, and the inner is the kernel, and between these two lies the cavity, and that is the work what we have to do. The outer coat is too hard to break, and the inner is too soft ki when the pressure is there or any force is there, it will be break easily. And the percentage what we see is that chironji nut contains nearly 70% of shell and 30% of the kernels. Now, regarding some of the initial studies says sir ki they needed 7 pass, and then we have proceeded it. So, it is seen ki usually horizontal type of the disc were used, and then after studying the what we can say force applied on for decortication, it is seen ki for outer coat we need a 136 Newton's force, and for kernels it is less. So when we have to decorticate, we have to just take care that it should just slide through that two disc, whereas it should not break the kernel. Now, these are few of the properties which we use for designing the decorticator. The unit consists of the grading unit, decortication unit, the sleeve assemblies with number of sleeves which can be used for grading unit as well as the decortication unit. Now, these are few of the diagrammatic things. Only the thing which what I need to explain here, or the thing which we have done is, yeah, here we can see the first picture. In that first picture, it is seen we have used small discs which are horizontal. That means when the travel of the nut is there, it is just breaking, and the second picture it is seen ki after breaking we are giving a space so that the kernel can move out easily. So this is the unit. Yes, these are the main things of all the work. That is the earlier IGKV Raipur what they have developed. The horizontal type of disc was used, and 80% was the efficiency.
Show your results.
Okay, so this is the procedure by which we have worked. Then these are the independence parameters and dependent parameters in which we have divided into small, medium and large size of nuts. So this type of results we have got, and then we have studied it for color, then water activity, hardness, protein content, fat content and sensory evaluation. So in the end, we can say that this was also checked for a number of 8 hours, 13 hours as well as 15 hours, and the grading efficiency was found to be 96 to 98%, decortication 79 to 82%, whereas the kernel what we got is 22 to 24 kg. So this 22 to 24 kg means out of those 30 kgs of kernel, rest 70% are shells. So also we have made a MOU with Madruka Plastic Works, and nearly 6 products we have sold up till now. And these are my final conclusions, in which we say ki the grading of chironji nut we get nearly grading efficiency of 98%, then decortication efficiency for large seeds. Large means 9 to 11, because the range is high, 4 to 12 the range is, so in this case 83%, then for medium we got 84%, and for small size we got 84.37%, along with good kernel capacity. So these are few of the salient features of my work. That is, it can be easily portable, it is small in size, and nearly we can purchase it by 73,000 like a bike. We can in that rate we can purchase it, and
Thank you,
many
madam.
of the self-help
Next,
groups
next.
are.
Thank you.
Sir,
Next.
so video is there, small video.
Okay, next. You are next.
Yeah.
Reducing drudgery
Video
of.
decodification next.
No, second.
एक
Ah,
sir
okay,
decodification
second.
video is there.
Second. No need.
Okay. Next.
Every extra minute that you are taking, your points are getting deducted from here.
Okay.
Everybody, this is for everybody.
Okay. So this is reducing tragedy of farm woman with Rosalie Callisis detector. This is a small gadget. Now you can see this. Everybody might have seen it. Okay, it is used for preparing jam, jelly, and bottle drinks due to its extra bright red color. And usually when it is freshly sold, it is sold at the rate of rupees 120 per kg. And when the value is added to it, then the price increases. These were the help of self-help groups which came to us for some of the help. And yes, this is the main aspect. We have to remove the outer calyces from that complete seed bowl or seed pod. So removing it is a tedious job. Yes, here we can see these are the Rosalie calyces, and here right side is the seed which is shown, seed pod, and it is having the whitish type of hairy structure, and that is the problem when manually we are removing it. Some itching is there and it can't be removed easily. And thus with the help of some of the ergonomical factors, we were able to see this is a small gadget type, and nearly 40 to 100 we have sold to our farmers without, we have given them the design, they have sold it. So nearly 50% of calyces and seed capsule is there. This is the manual work, this is the decortication with the help of detacher. Video on Karshil. This is falling under light work. Yes, this here she is doing manually, and while doing manually she is having a problem of itching, and after 2 or 3 she will be like doing the irritation type of thing happens. Next video. So with this we can find that we have already increased the capacity by 6 kg, means usually 0.25 something they used to do, and 6 times the capacity has been increased with the help of this hand tool. So this is one of the small invention which in every Kisan Mela and whatever is there related to farmers, they are coming and they are asking for it for the self-help group. Thank you, sir. Conclusion. Okay, these are the conclusions. So,
Okay. Any question from audience?
Any work on, excuse me,
please.
any work on continuous type are you doing?
Now we are trying to do it, sir. Because this efficiently is working, and now this is the basic design, now this basic design will be improvised.
Do you have any patent on this?
Not on this, but the earlier one, decomplicated. We have tried it.
Okay, thank you very much.
And this was easily approved by farmers, so design we gave us. Thank you, sir. Thanks, sir. Thank you for participating.
More.
Good afternoon, everybody. Myself, Pramodini More from Department of Agriculture Process Engineering, College of Agriculture Engineering and Technology, NMKV Parvani. Here I am present to present. Please next, please. Next. To the effect of risk of retreatment on the quality of the osmoconductively dehydrated RTE carrot cells. Next, please. carrots, we know that it is a healthy and nutritious vegetable and widely cultivated for its delicious.
Skip all
Yes,
the
sir, yes, sir,
introductory
yes,
part.
sir. So the next, please. So the osmotic dehydration.
Show your
were carried
objective
out
and
then
results.
The pre-treatments were blanching and freezing and thawing. Next, please. Here is the objectives, that is to study the effect of freezing and thawing process on the quality of RT carrot slices and to assess the overall acceptability of the osmoconvectively dehydrated RT carrot slices. Next, please. These are the treatments, that is the freezing temperature, 3 levels, thawing and control was there, and these are the dependent parameter to assess the quality of these RT carrot slices prepared with varying the freezing and thawing temperature. These are the formulas which we use to determine our dependent parameters. Next, please. Flowchart. This is the flowchart for the process, that is selection of carrots and washing. After washing, peeling, the slices were made of 3 mm thickness and blanching was carried out, that is the steam blanching for 2 minutes. Then the varied freezing temperature was -5, -15 and -25, whereas the thawing temperature were maintained for 5, 15 and 30 degree, and the osmotic dehydration parameters for the osmotic dehydration were kept constant, that is the 50 degree peaks osmotic concentration of the solution. Next. So this is the photographs of the process. Next, please. So here the first is the effect of freezing and thawing temperature on the mass transfer of the osmose carrot slices. If we see that the sugar gain and the water loss, less water gain and the sugar loss is recorded for the control treatment where there is no freeze-thaw treatment. And when we vary the freezing temperature for -5 to 25 degrees, so we can see that there is a decrease in the sugar loss as well as the water loss, because lower freezing, that is -5 and -15 degree temperature, there is a damage as compared to higher damage as compared to the -25 degree freezing temperature, which leads to less resistance to the mass flow, and hence the less solid gain and water loss is recorded for the treatment T7, that is -25 freezing temperature and 5 thawing temperature. Next, please. Next. Here is the effect of freezing and thawing temperature on the hardness, apparent density, shrinkage ratio and loss of shrinkage. Wherever the RT products are concerned, the porosity matters, and hence the apparent density, lower apparent density is the desirable, which we achieve in case of the treatment, that is -25 degree temperature and 75, that is thawing temperature, and the same is the highest ratio is desirable due to the porous structure of the product, and which is we got in the T7. Next, please. Next. And here is the color value. Next, please. Here is the effect of freezing and temperature on the sensory parameters of the RT carrot slices. The T7 treatment, that is the color, texture and flavor, and overall accepted the highest score for this treatment for the RT carrot slices. Hence, next, please. Next. These are the samples. Here the concluded treatment of -25 degree centigrade freezing and -5 thawing temperature before the osmoconvective dehydration resulted in desirable mass transfer, high retention of hardness and lower value of lower loss of shrinkage and high score all the sensory parameters. Thank you, sir.
Thank you, madam. Any question from audience? Thank you. Next.
Thank you, sir.
Madam.
Yes, what will be the cost of What will be the cost of production of this kind of RT using this from
400 rupees per kg, sir.
For how much it is sold?
Yes, sir.
For how much it is sold?
20 kg per kg for 8 hours. Process of the carrot.
Selling
Second product Thank you.
Extra natural colors.
Good afternoon, respected
chairman, coach, and the delegates. I'm going to present.
I'm going to present topic on extraction of can you move the slides? Yeah, extraction of natural color, that is beta sinin from the dragon fruit slices. As we all know, dragon fruit is gaining importance in India as well as in states like Karnataka, Gujarat, and Maharashtra. Almost it is reached 1,000 acres production of 8,000 tons, which is expected to grow. Yes, sir. So main justification is dragon fruit after processing
comes to what you have done.
Yes, sir. So objective is to standardize the extraction process for beta sinin from dragon fruit powder and to evaluate the characteristics of extracted beta sinin. This is the methodology what we followed. The dragon fruit after peel was taken and sliced 3 mm and dried in a humidified dryer which is optimized and milled in a normal pulverizer and extraction of color using different extraction methods we have used. This is actually this physicochemical properties were measured and approximate composition of fresh peel and dried peel powder was measured. And different extraction methods were tried like extraction using water, extraction using alcohol, extraction using citric acid as well as extraction using supercritical fluid. Since it's a polar compound, so extraction using water and alcohol where this was actually we can see the color extraction using water and alcohol were found best. So further water extraction was considered for further study, and these were the different treatments like 1:5, 1:10 and 1:15, 1:20. We have taken solid to solvent ratio and with a different extraction time of 4, 8 and 12 hours. This was actually the different with respect to the extraction time and extraction solid ratio. So we have got the results like extraction yield, pH, acidity and this one. In the treatment like 1:15 and 12 hours extraction time, we got a beta sinin content maximum of 86.38 milligram per 100 gram. And these were some of the graphs. The economics which we have worked out is almost 34 rupees per kg with a benefit cost ratio of 2.3:1. So this further it was taken to spray drying process with a feed rate of 50 ml and inlet temperature which was optimized and maltodextrin percentage and further the conclusion is the maximum yield what is in the 1:15 solid to solvent ratio and extraction time of 12 hours with a benefit cost ratio of 2.3. So thank you.
Any question? Any
Thank you. Next one is process technology. Next.
Actually, on behalf of Dr. Sudha, I'm going to present this. I'm also PI in this project. So this is the standardization of technology for Nannari extract instant powder. As we know, Nannari is a very good bundle of nutrients which carries and this is what the contains. It is a root crop which is harvested presently in the northern districts of Tamil Nadu, Andhra Pradesh. And presently it is not being processed or made into juice in a very hygienic way, very traditional way. They are doing it like a tribals, and this is how the traditional practice is going on. And Nannari it is coming in a big way in Karnataka and Andhra Pradesh. Almost near to 500 acres they are commercially cultivating it now. So the main challenges faced are enzymatic browning, microbial growth, and flavor changes because of the latex, which is containing in the roots. So this is what exactly the roots which Nannari roots were latex which is there in the and also the Nannari center part of that. So objective is to standardize the technology for Nannari extract, instant spray-dried juice. This is the process flow chart. The Nannari was extracted using different extraction techniques like boiling as well as microwave. And these were the treatments like for the spray drying process, 10%, 15%, and 20% maltodextrin with a different air temperature 160 and 170 degree. And this was the process chart for instance. This is the spray dried juice powder obtained at Drum and Cyclone of the Swan. These are the different Nannari juice powder. And this was actually the results which we got around 20% maltodextrin concentration and 170 degree. We got the highest product yield of 16.96%. This reconstitution properties also studied, and also the all other properties like Carse index, Nernst ratio, and other things. These were the TSS and other things what we have studied. Finally. Sensory evaluation and done, and this technology is almost commercialized in our areas. Microbial analysis cost almost a spray-dried powder now it is available at 1 kg of spray-dried Nannari extract instant 1,200. So commercially available it is around 500 rupees. So we can able to get a good profit out of this. These are the conclusion. Thank you, sir.
Thank you. Any question?
Okay, Dr. Mathur.
You said this is so much like I didn't understand the same also. Person has came forward to take this technology and we are in the process of making MOUs. Making these beverages and he wants to add a small Thank you so much. Next one is auto conditions by Pandey H. Well done. Next. Development of coaching Pandey. Yes. Optimization conditions. Okay.
17.
Respected chair, co-chair, reporters, and delegates. I am here to present work which is part of broader study to develop extruded product. Typically it is optimization of drying condition to prepare amla pomace powder. Next. So amla
Skip all these parts. Show your objective and results.
Next. So this is the process through which amla juice is being extracted. We are carrying out for 2 minutes, and then after that stoning is being carried out, and pulverization is being carried out, and finally juicing or the juice is being extracted, and the remaining pomace it is being collected. And the equipment of the machine. This is the pulverizer, and we are using type juicer for juicing. The amla pomace is a byproduct already we know it is rich in fiber. And for typically drying, we have used amla variety 2, which was being obtained from our university horticulture farm. It was being steamed for 2 minutes, and after extraction the pomace which was being collected, it was being dried at 3 different temperatures, 70 and 90 degrees centigrade. And typically this is the drying time and drying curve, specifically at 70 centigrade. And we were not able to find the typical falling rate. There were multiple curves which were being obtained at most of the temperatures for 70 degree. This is for 80 and this is for 90 degree centigrade. And these are the typical composition of amla and wet pomace and the pomace powder, and we find that the fruit fiber was quite high in the dried pomace powder, as well as the amount of this vitamin C content. It was also higher, around 131.81 milligram per gram of the product. And this particular result they were being obtained for the drying at around 70 centigrade. Because at higher temperature we were having lower values of vitamin C, and this typically was being selected as a best drying temperature. And this shows that there is significant effect of drying time and temperature on the product. And typically we conclude that we were having the moisture content of the pomace powder between 4 to 4.38, and the dehydrated pomace powder it was having highest vitamin content at 70 degree centigrade, 31.8 milligram, and the fiber content of the dried pomace was around 10.2%.
Thank you.
Some of the techniques which are there.
Thank you very much. Any question?
Okay, thank you. Next one. Development Govind.
I'm working as a scientist research. 80. Yes. So this work on development of a contemporary measuring machines for small scale and marginal scale chocolate farmers. This work was initiated under ARC on post-harvest engineering technology at KCAT under Kerala Agriculture University. So, as I go to the introduction, the status of chocolate processing industry in India is growing at a CAGR of 6.7%, which has a net worth of 3.8 billion during 2023. So, the chocolate processing, the biggest players of chocolate processing industry in the Mondelez and Amul, which shares about 55.9% of the industry. But what this particular research focuses on the remaining 5% of the chocolate manufacturing stakeholders that are mainly women and micro enterprises, including startups. So this chocolate processing involves a series of unit operations like this, of which we are mainly focusing on conching and tempering. Why conching and tempering has specially dealt is the existing machineries we are using industrially as imported ones which are having a very high cost of each machinery. Specifically conching and tempering machine individually cost more than 5 lakhs. So in our particular research work we have amalgamated both processes together in a single machine at a low cost to deliver the aforesaid stakeholders that mainly involve women and startups. And the main problem that we can identify in the homemade or cottage industry nowadays is a higher melting rate of the chocolate. That is mainly because no proper conching or tempering being done. Under this rationale, work was initiated to develop the conching and tempering machine and to optimize the process parameters for making chocolate under this mission and study the sensory analysis. These are the protocols and methodology being adopted in the work. And initially it was on design of the machine. The machine consists of a jacketed chamber which was made up of SS304 grade with an outer diameter of 3 centimeters and inner diameter of 5 centimeters that provides an 8 centimeter clearance space for the liquid or water to be circulated that has the provision to heat and cool. That is what we require in quenching and tempering process. Quenching is a high temperature grinding process and temperature is a relatively low temperature grinding process. Both of this has to be properly optimized to get chocolate of specific glossy finish and fat alignment that results in on-par grade of that of commercial chocolate. So the main problem identified by the cottage industry nowadays is that they don't have a chocolate that have a chocolate limited storage life that is getting easily melted when we are storing under ambient conditions. So to regulate this process, a proper tempering and quenching machine was being fabricated under this plant. The other components are being explained in the diagram. This is the stainless steel double vessel. This is the roller that provides grinding action to the mix. And the third one is the associated automatic control. Then comes the water storage tank of 7 liter capacity that is providing as a refrigeration medium to cool the process during the tempering. So these are the formulation being made. And the main sensory evaluation was done with respect to the one cottage developed, the Kerala Agriculture University developed commercial chocolate and the optimized chocolate. Together we have done the sensory analysis that comes to the range of this. That is, we are on par with the commercial grade chocolate. The melting comparatively less when we compare it with cottage level KU made chocolate and this other sensory scores and all the physical and rheological parameters of the mix was studied and chocolates are case in fluid which has a very shear thinning behavior. Specific studies were executed and the operational cost of the mission was coming around 97 with a benefit cost ratio of 1.87 when done under straight line cost analysis method and with a payback period of 2.5 years. These are the main observations which was on the development of the mission which is ready for commercialization with a minimum capacity of 10 kilogram of chocolate mix and all the parameters that is temperature, speed and of the mission is being optimized for a specific quantity and tempering and quenching is imparted. The training on this mission is already being imparted to the farmers and small entrepreneurs and there is a score for storage study of the developed product on a pilot scale model of the developed mission. Thank you.
Thank you very much. Any question? Any question? Next one. Promote.
Sir, I will finish within time. Yes. So, good afternoon, everyone. I am Pramod Sherke, working as a scientist at National Research Center for Tiruchirappalli. This work I am going to present that is in tissue distribution dynamics of ozone in bulk storage of onion by using computational fluid dynamics. This work I have done in CI Bhopal. So as we know, the increased price of onion has been the talk of the town. Now also if you say the price of onion is now almost 85 rupees per kg. So what are the major reasons? That is the post-harvest losses of onions are around 50%. So there are so many reasons behind this, and the major one is the spoilage of onion. So nowadays government is also taking initiative to reduce the spoilage of onion. These are the major spoilage microorganism for causing spoilage. So some decision measures are there, but now consumers perceptions is changing the residue-free technology, and here the role of ozone is important because this is the residue-free technology. It has strong microbial activity, residue-free technology is declared as a GRAS, but it's a reactive nature. If you apply in the bulk storage, difficult to the distribute. So considering all this, we devised our study into two objectives. First one, to model the ozone dynamics for onion bulk storage, and second one, design and validate dispenser for distribution of ozone in bulk storage. The modeling and simulation of ozone diffusion through the porous media of onion bulb were done by using CFD, and these are the assumptions we considered to reduce the computational power. A finite volume approximation method was used, and for defining ozone we used the organ equations. These are the model parameters we used: resistance, inertial resistance. Meshing was also done by using ANSYS platform. We run almost seven cases. Three phases we did. In first phase we check the effect of the headspace on distribution. Then we second phase we used half dispenser as well as the full dispenser. And third phase we used different full dispenser with different aperture size. And here we can see the spatio-temporal mass fraction of gases in storage domain. Here we can see first case without headspace, without dispenser. The distribution time was around 1740 seconds, but with optimized dispenser, it is reduced to 360 seconds. This is the temporal ozone concentration at location, non-uniform coefficient. Then they fabricated the dispenser and we studied the simulated experimental temporal ozone concentration, and the relative error was observed 10%. Then we also checked the different storage parameters, and we observed that the ozone treated periodically ozone treated bulbs, lower microbial count. Then also we studied the physiological parameter. Rotting percentage was also periodically treated, that is 15.46%, and untreated around 35%. Then we also studied the biochemical parameter like pyric acid, ascorbic. It was reduced during storage, but phenol and ionic acid initially, then it is decreased. Then also we studied chromatography. Then silent that is the dispenser with smaller aperture 2 mm in headspace, 4 mm medium hole in upper section, and 10 mm hole in larger apparatus gives the uniform and effective application. The overall we can say ozonation reduce the rotting percentage in onion bulbs during storage minimum alteration in quality parameters. Thank you.
Thank you. Any question?
Let me conclude. Very good. Once we store only so this is the batch type. So just for your information, we have other efficiencies here. We have now approach massive data. So you can share onion gas history. So this is a big problem. Don't have the solution. So we need the CSE experts also. So we can learn one time. So So that we can multiply. So we will like that. This will be the solution. Thank you. Next one, can prove that is a machine. Gupta.
Good afternoon, everybody. As we know, cashew nut is eaten by everyone across the country and the world. But the cashew comes attached to the fruit, which the cashew apple, which needs to be separated. It's usually done manually. And so this is a drudgery operation, and hence there was a need for development of this machine. This is not a machine developed by me; it's by my client. Three machines have been developed by them of varying capacity. I'm giving the performance characteristics of this machine. Next slide. Okay. This is the operation machine. There are three feed rates.
Continue.
There are three feed rates ranging from 5 to 6, 3 to 4, and 1 to 2 kg per minute. It's fed in a hopper of 50 kg. It comes to the upper barrel where there is a rubberized crusher. From the crusher, pulp juice is directly conveyed down below the machine and removed. And the cashew fibers with the nut is then forced through the conveyor system, which has four or one paired rollers. And here by the opposite rolling the device, the fiber is pulled down and the nut is conveyed on the it comes out of the this is the operation.
Feeding थोड़ा fast
Fed here and below this, as you can see, the pulp comes down and the nut comes from this section and removes the the cost of the machine varies from 75. That is the highest machine. Capacity machine has a thorough capacity of 300 to 400 listen. Second machine is okay. I need to go to the previous slides. Doesn't go backward. Yeah, previous one. Okay, next. Okay. The machine. This is the second machine. 2,00,000. You can go to the next machine. And the third machine is around this one. The material of construction, as you can see, is MS. Those are not very important for this. And the operation, the capacity vary from 18.55. Like I'll in the final slide only. Okay. The machine characteristics capacity varies from 25 to 136 and 84 for three machines. And that was for the nut. And for the nut it was 975 and 12 kg per hour. And the machine could be operated both using petrol operated engines or electricity. And the fruit separation was around greater than 95%. And there was a choking problem for the smaller capacities. For the three conveyor belts, there was no choking. That was kind of modified by our suggestion with a better angle of the output and output opening. And we have suggested since in all other states where cashew is grown, only the nuts are being processed. But in Goa it is processed for fenny. And so in our state we have said that it has to be of the system for crushing has to be in stainless steel 4004. And these are the suggestions that we have given. So thank you.
Thank you, madam.
Any question? Okay, thank you. Next. Receive development of same extension from Sendable using the protocol, not AMI.
Good afternoon to all. Respected chairman, co-chairman, reporters and dear delegates. So we are presenting such review work, recent development on extension of cuts and vegetables using edible coating. Actually, at presently we are doing some research extension work on extension of shelf life of different fruits using edible coating, functional coating, and on that we are doing, and all are doing that. Next. We all are doing that fresh cut fruits and vegetables having lot of importance due to rich in fiber, rich in vitamins, convenience, and at a single pack we are getting lot of fruits, and but main problem is very short shelf life, and there is more main issue is chemical preservatives especially used in general in fresh cut fruits and vegetables. This is the statistics means among all fresh cut fruits around 24% of total markets. This is the spoilage is highest we have observed in fruits and vegetables. What are the consequences? We all are knowing. That means fresh cut means mineral processing. We are doing peeling, cutting, and coding of seeds, etc. And by doing these methods, we are increasing the distribution rate as well as increasing shelf life and increasing of solid productions. The things enzyme also increases surface water content. Moreover, sensory quality as well as microbial growth is increasing, but sensory quality decreases. Means out of these lot of research are going on presently, but not a single research is soundproof. There were therefore lot of technologies developed, and combination of many of the technologies, invisible coating, light, UV radiation, control spheres, many other things. With hurdle we have to use one or more technology for extending the shelf life. These are the simple classifications. We all are knowing that edible coating having polysaccharides, protein based, and composite combination of more materials. These are the major functions. We all are knowing that barrier properties, control sphere, mechanical properties, bioactive functions. These are things. Then impact of edible coating. These are the technologies. These are the procedures, commercial scale of fresh fruits. These are the recent reviews. We have seen that maximum enhancement. This is one experiment we have research found that only 12 days can be extended.
Conclude.
Means edible coating with nano emulsions and very some hardware technologies examples, and these are the patent very limited patents are filed from India, very less not available on nano emulsions. Recommendations large scale studies are needed, and natural best edible coating is essential. New stable innovations is needed because most of the technologies are not supporting or commercially supporting.
Thank you, Dr. Prasad. Thank you very much. Any question?
Thank you, session.
And one of the lecture which we did food crops in home in homestead farms as an enterprise. Dr. Achina, please make it as short as possible for you.
Thank you, sir. I think so far we are just listening to different technologies. Here talking about how KVK Kendra, how we promoting different technologies at farm level, study level, process different value products which are grown in that region. So any village level, specific level, regional level we have carried out. I will show some of the photos what we have done. Next slide, please. So this homestead processing is kind of how we hearing about backyard poultry. Similarly, homestead processing at a farm level, which we can achieve the sustainable goals, especially the sustainable goals which are poverty, zero poverty, zero hunger, and health and well-being. These can be achieved when we process the foods at the homestead level, create a livelihood, and we can ensure the food security. We can also promote the diet diversification. Next slide, please. So through this, we have a PMFIB to support these kind of processing units with minimum capital investment, support from the government of India. Next slide. So these are the issues we are witnessing for the last 20 years. So there is a need to save the grain. So when you save the grain, automatically productivity will also increase. Next slide. So these are strengths, opportunities and threats. Next. So actually our KVK Adilabad is very dominated area. Majority of the population are aboriginal tribes. So there is a major issue. We have very less livelihood opportunity. So to create livelihood opportunities as well as the malnutrition, we have promoted different technologies at the home level. Next. So we have established multi-purpose floor mills, different villages where they can process their locally produced millets, grains, other spices in the district. Next. Through which we have promoted. So every beneficiary is getting around 5,000 rupees. And whatever the products we are promoting through Adilabad technologies, and we also established one store like more supermarket or Reliance kind of supermarket in the district headquarters. So those products are sold in that supermarket. I will show the product. Next. So this is the one unit we have established in the tribal area, where making different products. Next. So these are the multiple mixes we can prepare, and given the technologies they are promoting this. Next slide. So this, and we also promoted these sprouted grains. Next, keep on. Next. And millet processing, we have also established one incubation center. We are also promoting dal mill, the farmers level. Next slide. And we are also promoting this Mahua value addition, Maddu beverages. Soybean is also major crop. We are promoting tomato is a major crop in tribal area. We are promoting when the gut season of tomatoes dropped out. Then we are encouraging the farmers to go for value addition to onion when prices dropped out. Next. We are also promoting drumstick leaves, value addition, solar drying. We have established solar dryers in different locations. Next. We are also promoting the chili, small scale grinding units. Next. Hand pounding chili machine. Next. And we are also promoting this Adilabad town to different hotels. We have established one cooking kettle where they can biryani mix, mutton curry mixes, and they can send to their hotels. Next. And we are also promoting the turmeric value to grinding mills. Small scale units, less than 1 lakh. We also promoting turmeric value golden milk preparation. Next. And mango picking during season. Whatever the seasonal fruits, local in the district. All the crops we are converting into value-added products during the off-season, glut season. So they can produce their produce and at least additional income of 25 to 30,000 extra per annum processing and value addition of different crops. Next, Amla. So this is the store we established through Aqua Funds and Tribal Supply Fund. Through this store, all the farmers, whatever they produce, and they sold in this supermarket, and the people they buy from this supermarket. And these products are higher than the locally other branded products and other things. So with this, we are trying to achieve the homestead processing as a diversified livelihood opportunities for farmers and self-help women, rural youth, and employment opportunity to address the malnutrition, and also to promote the diversification in the district. Thank you, sir.
Thank you very much. Thank you giving a time also. Nice work. I had a question. We are from
Districts, sir. So we have concept of dragons and concept of archiving, and we also supported funds and
it's good. I compliment you for making a suggestion of Thank you. I have a suggestion that I don't know, but you should come success stories. Thank you. Any other question? No, thank you. Okay, we have another presentation. Three-cone. Yeah. This is transforming through IoT and Sandeep Mahan. The last one.
Respected chair, and fellow delegates. Thank you for preponing my presentation. So, just to give you an overview how this the future of animal farming, animal housing will be there in our country, and how we can associate youth and the people who are interested in the business with the use of technology and what type of technology they can use. So basically, we all know about IoT and role of AI is increasing. And this field is also starving to take these technologies and these technologies are required for the management and of our animal maybe extracting information from field and getting information and then processing those information for different dimensions. So basically, if I talk about this IoT architecture, so there are four layers: application layer, network layer, and physical layer. So in physical layer, we are extracting information, different information like animal health, temperature, how they are roaming. So that type of information, the network layer is there, and after that transport layer is there, and then application layer is there. So this IoT and AI revolve around these four layers basically. So basically, we wish to monitor health status of animal, their movement, body temperature, digestive activities, and the sensor and actuators, has a great role in that. So there are so many communication protocols can be used for that. And sensor can be external or invasive. So nowadays like neck collar we are using. So these type of external sensors we are using for the monitoring of the animals in India also. But you have a long way to go. And there are many applications can be there, and we need to develop indigenous sensors for that purpose with specific reference to different animals. So I listed down these type of sensors are required for different applications. And for this AI based precision livestock farming, we require animal monitoring sensor. Then So this can be, you know, a model basically, AI-based animal welfare monitoring and for identification of disease and how our animals are behaving. So nowadays, you know that small dairies has no future basically. So we have to make this farming profitable by using different type of technology. So there is a scope for, you know, agriculture engineers to develop such type of applications that can be used. Like we can take this activity pattern, movement and posture analysis. So this is a scope, and by using imaging like face detection and using of AI. So these type of applications are required. Okay, so time is less. Like monitoring of heat stress, that can be measured by monitoring of the temperature. Of course, many diseases like lumpy disease, we can detect by using sensors, and we can isolate and take decision, which we can, you know, if we are using these technology, we can detect quite in advance. So basically, it's not like that these technologies are there in developed countries. People are using such type of farms are there where they are monitoring sensors. So almost, you know, 200, 300 kettles are being monitored by 2-3 people because labor is not willing to work for these dairies. So we need to automate this. So I am just skipping these things. I'm quickly coming to, you know, so there is a scope of application for this monitoring of milk quality also. Not all, that is not limited to the animal health, and of course scope of robotic milking parlor. So basically at CFET we also planning to do some work in this direction. So, you know, this is this is the detection of the movement of the cattle through camera, and we can detect that whether this is healthy or not. So now this type of work we are doing at CFET, and we wish to develop some, you know, urban cattle housing structure by incorporating these IoT things like that. So that is the, that's all from my side. So this is the area I invite students and researchers to put their focus on it so that this sector can use technology, and a lot of automation is required. Thank you very much.
Well, thank you very much, Dr. Mai. Any comments from the house? No, then thank you very much.
Thank you, sir.
So with this, we come to the end of this session. In this session, there were 19 presentations made. 13 were listed, and then 2 were lead lectures, rather 3 lead lectures, and 3 were presentations from the other session, designated for other sessions. We took almost, I should say, 120 minutes with a break, so almost 6 minutes per presentation. That was the statistics. So before I give my remarks, I would request my colleague, Dr. Niloni, to kindly give his remarks before we conclude the session.
Thank you, sir. And especially in this second session, it started late, but we could complete the session in time, even covering the previous presentations also. And here in this session, I think almost all kinds of presentations were there, starting from the unutilized fruits and other commodities, and including the high-valued cocoa commodity also. I think this session has covered almost all kinds of commodities and related research presentations. And I think I must compliment all the presenters, researchers, and even including the students for their nice presentations. Thank you, sir. Thank you very much for giving me this opportunity.
Thank you, Dr. Nironi. Before I give my concluding remarks, I should thank my reporters, Dr. Kad and Jyoti, right? Okay. And I will also thank the organizers for giving me this opportunity. In this session, we have seen presentation on product development, on machine development, on infrastructure that is available for research, on some futuristic technologies, on testing of equipment which are commercially available, and also on technology transfer. So a good diaspora of technology has been covered during this. Some of my comments could be critical, but I feel it is important to say that some of the slides had unnecessary data, and this was very much distracting the speaker himself other than audience. Time adjustment is one of the challenges that I put in front of you. Although there was some exceeding and there were some technical glitches also. So 3 minutes were given and then 6 minutes were taken on an average. So that we should think ourselves that how this can be reduced. In majority of the work, even the machine development also, we, except for one or two, we lacked presenting the design things or engineering interventions. That is must. That is where we show that how engineering has been employed. Other than that, any blacksmith can also develop a machine, and how engineers have given input that has to be reflected. Same thing about the product development. So mass transfer, heat transfer, flow behavior. So these type of things we need to make focus on our presentation, so that even when the students who are working on or listening to this, they get motivated for that. Then some presentations lags were also there, but to cover up all these things, I was just thinking that ISA should consider, especially our Vice President is also sitting here, so he should consider conducting a seminar or maybe a workshop on presentation skills. How to prepare presentations for which occasion. Many presentations in this session and even in previous session, they were simply like copy of thesis. So that is not expected in these type of places. And all of us, we are visiting this ISA convention since many years, and we know that time constraint is always there. Sometimes it might happen tonight that for sake of dinner, people will be asked that come in front, show your title and show your conclusion. So it might happen. So we know that this situation is not uncommon, so we should come prepared for that. And for that, ISA should also handhold, maybe conduct a few workshops on preparation of presentation, preparation of slides, using of units. I have seen many people using wrong units or writing them wrong, not by SI unit. So these type of some of my suggestions and comments are there. Anyway, I compliment all of you for making a good presentation. I am very happy to see the AV8s, use of AV8s has been quite effective. The font size and all, more or less it was good, color schemes, more or less everybody did very good. I compliment all of you. I thank organizers once more.
We are at the end of this session, that is the technical session, oral offline as well as the online. I am very much thankful to Dr. Nachiket's Director CPET Ludhiana for honoring this chair as a chairperson for this session. I am also thankful to the Dr. Udai Kumar Nironi sir, Head, University of Agriculture Sciences, Dharwad, Raichur, to honor the chair as a chairperson for this session. I am also thankful to our two reporters, Dr. Vikram Kar sir and Jyoti Dakne madam, and all the dignitaries in the house. Thank you once again.
we will take 5 minutes break. Tea is available outside. Tea is available outside. But within 5 minutes, please gather here, and we have to start next session. That is the third session on novel technology. So please, we are short of time. Already running on 2 hours late. So almost at this moment we may finish it by 8, and if we extend it, it may go to 9. So please, within 5 minutes, gather in the hall. Already the participants are less, so somebody should be in the audience. So I request all the participants, please come in 5 minutes. 5 minutes. High tea, 5 minutes, that is also a challenge. Or otherwise you can have ET.